The law of the conservation of energy states that energy cannot be destroyed or created. It can only be changed from one form to another or transferred. In the diagram, you can see how the different types of energy are transferred or transformed. Heat is a form of energy. It is caused by the movements of the atoms and molecules in a substance. Heat transfer occurs when the atoms and molecules collide. When the molecules collide, some of the energy from the faster-moving molecule is transferred to the slower-moving molecule. Heat transfer only occurs from warm to cold. Hot and cold are adjectives used to describe temperature. When finding the temperature of something, you are only finding the heat intensity. What is important is you understand that you are not finding out how much heat something has. You are only finding out how hot or cold it is. Two most common temperature scales used in the HVAC industry are the Fahrenheit scale and the Celsius scale. They are based on the melting of ice and the boiling of water at sea level. It is important that you are able to convert between the two scales. If in the picture of the thermometers they were to show all the temperature hash marks between the temperature ice melts and water boils, the Fahrenheit thermometer would have 180, while the Celsius thermometer only has 100. So for every 5 marks on the Celsius scale, you have 9 on the Fahrenheit scale. Since on the Fahrenheit scale the melting of ice is at 32, and on the Celsius scale it is 0, you have to add 32 degrees when converting from Celsius to Fahrenheit and subtract 32 degrees when converting to Fahrenheit to Celsius. Also, when looking at the formula, you notice that part of the equation is in parentheses. If you remember from high school, when you're solving an equation, you have to follow the order of operations. So the first thing you would do is solve the part of the equation that's in the parentheses. When talking about how much heat energy something has, we measure the amount in BTUs. The definition of a BTU is the amount of heat needed to raise 1 pound of water 1 degree Fahrenheit. As an example between the amount of heat energy and the temperature of something, a kitchen match contains approximately 1 BTU of heat energy. The temperature when you light the match, though, is between 1100 degrees Fahrenheit to 1500 degrees Fahrenheit. When finding the amount of heat in a substance, what we are doing is calculating how much heat was added or removed to bring the substance to its final temperature. The formula for finding the amount of BTUs that are transferred is to multiply the specific heat capacity of the substance by the mass of the substance by the temperature change. All substances have a specific heat capacity. The definition of specific heat is the amount of heat required to change 1 pound of a substance 1 degree Fahrenheit. If you notice, the definition is very similar to the definition of a BTU. The difference is a BTU is about water. Specific heat capacity is about a specific substance. It takes exactly 1 BTU to change the temperature of 1 pound of water 1 degree Fahrenheit. So the specific heat of water is 1 BTU per pound. The specific heat of iron is 0.129 BTUs per pound. To change the temperature of iron 1 degree Fahrenheit, you only need 0.129 BTUs per pound. If you notice in the formula, there is a triangle and a T. We call that a delta T. What delta T means is it's the difference in temperature. When actually applying the formula, before you can multiply the delta T, you first have to subtract the initial or beginning temperature from the final temperature. At this point, I'd like you to pause here and attempt the 2 problems at the bottom of the slide. The answers are on the next slide. So following the formula, the first thing you'd want to do is find the temperature difference. So you take the final temperature, which is 100, and you subtract 70 from it. You come up with 30. So the amount of heat required to raise the temperature of water would be 1 BTU times 10 pounds times 30 degrees Fahrenheit, which equals 300 BTUs. The amount of heat required to raise the temperature of iron would be 0.129 times 10 times 30, and it equals 38.7 BTUs. Heat transfer occurs three ways: either convection, by conduction, or by radiation. Conduction is the flow of heat through a solid or between two objects touching. In the picture, we have a pan sitting on a hot stove element. Since the pan bottom is cooler than the hot element, heat energy is going to be transferred from the stove element to the pan by conduction. Since the pan is a solid, the heat is going to transfer from the bottom of the pan to the inside where the bacon is. And from that point, the heat's going to be transferred to the bacon because by conduction, because the pan and the bacon are also touching. Convection is the flow of heat by the motion of molecules in a fluid. A fluid can be either a gas or a liquid. How it works is as the gas or liquid is heated, it becomes less dense and rises towards the top. The more dense, cooler gas or liquid then falls and gets heated. At that point, you form a convective loop. Radiation is the transfer of heat by electromagnetic waves. Light, microwaves, X-rays, TV, and radio waves are all kinds of electromagnetic waves. When the electromagnetic waves encounter an object, it transfers heat energy to that object. Electromagnetic waves will only move in a straight line. Looking at the picture, you see how the waves are depicted as straight lines. It is because they will not curve around an object. Think about the sun and the earth. Only the part of the earth that is facing the sun receives the light. The other side of the earth is dark. Substances exist in three states: solid, liquid, and gas. What state a substance is in is dependent on the temperature, pressure, and heat content. At atmospheric pressure, water remains a liquid from 32 degrees Fahrenheit to 212 degrees Fahrenheit. Below 32 degrees Fahrenheit, it becomes a solid. Above 212 degrees Fahrenheit, it becomes a vapor or gas. During heat transfer, heat is either being added or removed from a substance. When adding or removing heat, and there is a change in temperature but no change in state, it is called sensible heat. When adding or removing heat and there is no change in temperature, but there is a change in state of the substance, it is called latent heat. The graph depicts how much heat is transferred to a pound of water at different temperatures and the different states the water is in. When the water is in the solid form, it takes 16 BTUs of sensible heat to raise the temperature from 0 degrees Fahrenheit to 32 degrees Fahrenheit. At 32 degrees Fahrenheit, an additional 144 BTUs of latent heat is added to the ice to melt it and turn it to straight water. An additional 180 BTUs of sensible heat is then added to raise the temperature to 212 degrees Fahrenheit. It takes an additional 970 BTUs of heat to change the water to a vapor. Temperature, pressure, and volume are all related. Temperature and pressure are directly proportional to each other. What that means, if temperature increases, so does the pressure. If the temperature decreases, the pressure will decrease also. Pressure and volume are inversely proportional to each other. What that means is if the pressure decreases, the volume will increase, and if the pressure increases, then the volume will decrease. Volume and temperature are also related. Just as temperature and pressure are proportional, so too are volume and temperature. If the volume increases, the temperature increases, and if the volume decreases, the temperature decreases. As an example, let's use boiling water. At sea level, water boils at 212 degrees Fahrenheit. If you were 2,500 feet above sea level, water will boil at 207 degrees Fahrenheit. It does so because there is less pressure. At sea level, the atmospheric pressure is 14.7 pounds per square inch atmospheric. At 2,500 feet above sea level, the pressure is 13.4 pounds per square inch atmospheric.